Welcome to the homework video guide on factoring trinomials, and my plan for this particular video is to do a review on how to factor trinomials when your leading coefficient is equal to 1. Alright, so let's take a look at question number 1 here. For question number 1, you have a trinomial here, b squared plus 8b plus 7, and you do have a leading coefficient of 1 here in red. And once you have a leading coefficient of 1, you should right away set up a little table here on the side. And the goal to factor these kind of trinomials is that you need to find two numbers that multiply to 7, and those two numbers need to also add to the middle number here, which is 8. Alright, so you need two numbers that multiply to 7, and those two numbers need to add to 8. So the numbers that work in my mind are 1 and 7. 1 times 7 is 7, and 1 plus 7 is equal to 8. After that, since you have a leading coefficient of 1 here, you want to set your brackets like this, and you should have the variable b to start off, b and b. Remember, b times b gives you the b squared. So have the b's there, and then the numbers 1 and 7 that you found on your table, those are the numbers that go inside your brackets. And that's your final answer. The order does not matter, so if you want to write b plus 7 times b plus 1, that's also correct. The order doesn't matter when you're multiplying those two terms. Okay, let's move on to the second question here. Once again, in this problem, the leading coefficient is 1 there. So once you have a leading coefficient of 1, you should set up a little table on the side here. And the plan is you want to find two numbers that multiply to 10, and those two numbers need to add to negative 11. Alright, so let's put a 10 on my table there. So there's a 10, and here's my negative 11. And the two numbers that multiply to 10 are 1 and 10. So 1 times 10 is 10, but unfortunately those numbers don't combine to negative 11. So in order to fix that, just put a minus sign in front of the numbers, because negative 1 times negative 10 is positive 10, and negative 1 minus 10 is equal to negative 11. Alright, then you can set your two brackets. Because you have a leading coefficient of 1 here, you can have the variable n here and the variable n there. And then go back to the numbers in your table, negative 1 and negative 10, and those are the numbers that will go inside the brackets. So negative 1 and negative 10 there. Okay, let's move on to the next one. Question number 3. Once again, we have a leading coefficient of 1 there, so you should set up a table right away. And you want to find two numbers that multiply to negative 90. And you also want to find two numbers that also add to the middle number, which is an invisible 1 here. Okay, so that 1 is over there. Okay, and two numbers that multiply to negative 90, I'm thinking like 10 and 9. And one of these numbers must be negative because I need negative 90. And you should put the minus sign on the 9 because 10 minus 9 gives you the 1 here, right? And 10 times negative 9 gives you negative 90. Alright, so now you can set your two brackets. Since you have a leading coefficient of 1 there, you must have an m here and an m there, because m times m gives you m squared. And your numbers are 10 and negative 9. So this would be plus 10 and minus 9. Alright, let's move on to the next one. Once again, there's a leading coefficient of 1 here, so let's set up the table here. I need two numbers that multiply to negative 12, and those two numbers need to add to 4. So two numbers that multiply to negative 12 and add to 4. The numbers I'm thinking are 6 and 2. And the negative sign should go on the 2 there, because 6 times negative 2 gives you negative 12, and 6 minus 2 would give you the 4. Alright, and then you set up your brackets here. And since you have a leading coefficient of 1 there, you need to have the variables n. You need an n here and an n there. And the numbers that we found were 6 and negative 2. So this would be now plus 6 and minus 2, and that would be your final answer there. Alright, question number 5. Once again, there's a leading coefficient of 1 there, so let's set up a table. we need two numbers that multiply to 9, and those two numbers also need to combine to -10. All right, so think of some numbers that actually multiply to 9. So I'm thinking 1 and 9. So 1 times 9 is definitely 9, but then I need the -10 there, so it's probably best to put negative signs on both of the numbers there, because two negative numbers, when you multiply them together, you get a positive number, which is 9, and -1 minus 9 gives you -10. All right, and then we separate brackets, two brackets, and because our leading coefficient is 1 there, the variables I need are n and n. N times n is n squared. And the numbers I would now use are the -1 and the -9. So this would be -9 and -1. And there you go. That one's done. Question number 6. Once again, there's a leading coefficient of 1 here. So we will set up a t-table. I need two numbers that multiply to 64. And those two numbers need to add to 16. This one's not too bad because 8 times 8 gives you 64, and 8 plus 8 gives you 16. All right, so then we separate brackets, a b here and a b there because the leading coefficient is 1, and then our numbers are 8 and 8, so plus 8 plus 8. Now this is a correct answer. If you want to write this as b plus 8 all to the power of 2, this is also another acceptable way of writing the final answer. But both ways are totally fine. Okay, let's move on to question number 7. Once again, for question number 7, there's a leading coefficient of 1 there. So let's set up a t-table here, our table there. This is going to be -24, the last number. So -24 goes in the table. And then we also have a plus 2 in the middle. So 2 would be on the other end of the table there. All right, so we need two numbers that multiply to -24, and those two numbers need to add to 2. All right, so if the number is big, then what you could do is always start off with the number 1. So 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is equal to 24. And then I have 6 times 4 equals to 24. Now the goal is I should definitely focus my attention on these numbers here because the 6 and the 4 can give me the 2. And all I have to do to modify that is I need to put a minus sign on the 4 there, because 6 times -4 is equal to -24, and 6 minus 4 gives me the 2 there. All right, so we set up two brackets. And the variable here is now m, so it's m times m. So m times m is m squared. And my numbers are 6 and -4. So plus 6 and minus 4. Great. All right, let's move on to question number 8. For question number 8, the leading coefficient is 1. So set up a table right away. And the two numbers that you're looking at are 24. And the other number is -4. Okay, so 24 is kind of a bigger number, so let's find out all the numbers that multiply to 24, the two numbers that multiply to 24, so 1 and 24, 2 and 12, 3 and 8, and 6 and 4. Now, I'm going to stop there because when I look at all these numbers here, if I look at the numbers like 6 and 4, 3 and 8, 2 and 12, 1 and 24, none of those combinations can help me get to a -4. So I can't think of two numbers that multiply to 24 and those two numbers would give me like a 4 combination. So for this one, I'm sorry, but we actually can't factor because it's impossible to find two numbers that multiply to 24 and those numbers wouldn't be able to combine to give me a 4. So that one we can't factor. All right, let's move on to the next few questions here. So question number 9, once again, there's a leading coefficient of 1. So we can set up a nice little table here on the side. And the numbers that we're looking at are 40. And we're also looking at the middle number here, which is -13. All right, so our goal is I want to find two numbers that multiply to 40, and those two numbers need to add to -13. So two numbers that multiply to 40 are 8 and 5. 8 times 5 is 40. And in order to get the negative 13, it's best to put a minus sign in front of those two numbers. And negative 8 minus 5 gives you negative 13. All right, so let's go ahead and set up two brackets here. And since we have a leading coefficient of 1 there, the variables that we need at the front are k and k. K times k is k squared. And the numbers that we want are negative 8 and negative 5. So this would be negative 8 and negative 5. And that's how you factor that one. All right, let's move on to question number 10 here. There's a leading coefficient of 1 there at the front. So let's go ahead and set up a table. And the two numbers that I want this time are 18 and the middle number here, which is 11. So two numbers that multiply to 18 and add to 11. That one's not too bad. I'm thinking about 9 and 2. 9 times 2 is 18, and 9 plus 2 gives me the 11. All right, so let's set my two brackets. Because there's a leading coefficient of 1 there, I should have an A here and an A there. And the numbers I want are 9 and 2. So A plus 9 and A plus 2. And that should finish that particular problem. All right, a couple more here. So once again, leading coefficient of 1 there. So let's set the table. And there's a negative 56 here. And the middle number here is actually a negative 1. All right, so if there's a minus sign there with no number, there's an invisible 1 there, so it's minus 1. Two numbers that multiply to 56 are 8 and 7. Now I need negative 56 and I need those two numbers to add to negative 1. So it's probably best to put the minus sign on the 8. So that would give me two numbers that multiply to negative 56. And negative 8 plus 7 would give me the negative 1. And if I set my two brackets here, my leading coefficient here is a 1, so I need a variable n there and n there. N times n gives me the n squared, and negative 8 and 7, those are the numbers that would go in the brackets. So negative 8 and positive 7. Great. Moving on to question number 12 here. So I think we now get the hang of these kind of problems. So we can go right ahead and set the t-tables right away. 6 and negative 5. Two numbers that multiply to 6 and combine to negative 5. I'm thinking 2 and 3. And since I need negative 5, both numbers should be negative. So negative 2 times negative 3 gives you 6, and negative 2 minus 3 gives you the negative 5. So final answer here would be n minus 2 and n minus 3. And these numbers here, they're the numbers inside the bracket. Okay, let's move on to question number 13. Leading coefficient of 1, so I need a t-table here. I need two numbers that multiply to 8, and those two numbers need to add to negative 6. All right, so the two numbers that multiply to 8 and add to negative 6, well, you can do a few combinations here. 1 times 8 gives you 8, but that won't give you the 6. Then 2 times 4, that would give me the 8. And in order to get the negative 6 there, both these numbers should be negative. And that would now give me the negative 6 if I combine them. So negative 2 minus 4 gives me negative 6. All right, so now we need two brackets. Since there's a leading coefficient of 1 there, the variables are always, the starting variable. So b times b is b squared. And then you would need the negative 2 and the negative 4. And once again, these numbers are right there. Okay, let's move on to question number 14. Once again, there's a leading coefficient of 1 there. And I need a t-table here. So here's a plus 8. And the middle number here is plus 6. All right, so two numbers that multiply to 8 and add to 6 are 4 and 2. And then we can separate brackets. And now we can simply insert the numbers there, n plus 4 and n plus 2. Okay, so that 4 is that right there, and that 2 is that one right there. Good. We got a couple more of these. We have 4 more of these. All right, so let's just quickly do these. Leading coefficient of 1. Set up my table there. I need two numbers that multiply to 10, and those two numbers need to add to 11. that was not too bad. This is just 1 and 10. 1 times 10 is 10, and 1 plus 10 is 11. So this would now become p plus 1 and p plus 10. And once again, this 1 is that guy right there, and that 10 is that guy right there. Okay, moving on to number 18 here. There's a leading coefficient of 1 there. Let's set up a t-table here. The two numbers I'm looking at are negative 90. And I'm also looking at the middle number here, which is, well, there's a negative sign there, so that means the middle number is just negative 1. All right, so two numbers that multiply to negative 90 and add to negative 1. I'm thinking about, well, 10 and 9 give me 90. And in order for me to get the negative 1 there, the minus sign should definitely go on the 10, because negative 10 plus 9, that would give you the negative 1. And once again, the two brackets, a minus 10 and a plus 9. Those are the combinations that would work. So this is negative 10 right there, and this is the 9 right there. Okay, moving on. We have 3 more questions on a leading coefficient of 1 here, and then we'll move on to some different kind of problems in a bit. All right, so let's set up the t-table once again. The two numbers that I'm looking at are the last number here, 50, and the middle number is negative 15. So we need two numbers that multiply to 50, and those two numbers need to add to negative 15. Well, two numbers that multiply to 50 are 10 and 5. And in order to get to the negative 15, we should put minus signs on both of those numbers, because if you multiply two negative numbers, you get a positive number. And negative 10 minus 5 would give me the negative 15. All right, so final answer here, two brackets, x and an x. All right, so x times x gives you the x squared. And then I need the negative 10 and the negative 5 there. All right, so this negative 10 is there, and this negative 5 is right there. Okay, moving on to 24. We have a leading coefficient of 1 here, so let's set up a t-table here. All right, so the numbers I'm focusing my attention now are 10 and negative 7. So two numbers that multiply to 10 are 5 and 2. And in order to get to the negative 7, I should have minus signs on both of those numbers, because if you multiply two negative numbers, you get a positive number. And negative 5 minus 2 is going to be negative 7. All right, now we set the brackets here. This is going to be p, sorry, not p, but v. All right, so v times v gives you the v squared. And then we need the minus 5 and the minus 2. So there's my minus 5, and there's my minus 2. All right, let's do one more here. The leading coefficient here is 1, so let's set up a table here. Circle the last number here, which is negative 18. And the middle number here is positive 3. And I need two numbers that multiply to negative 18, and those two numbers need to add to 3. So numbers that multiply to 18, I'm thinking 6 and 3. And in order to get to the positive 3 there, this should be a minus sign on the 3 there, because 6 times negative 3 gives you negative 18, and 6 minus 3 gives you the 3. All right, so now we need two brackets, a p here and a p here. Remember, a p times p gives you p squared. And then I need the plus 6 and the minus 3. All right, so that 6 is over there, and this 3 is right over there. All right, let's move on to a few other questions here. Now, in the next few problems here, you'll notice that the leading coefficient is no longer 1. If your leading coefficient is no longer 1, I guess I'll call this part 2 of the video now, because when you don't have a leading coefficient of 1, what you should do next is you want to look at the rest of the numbers here. So there's a plus 6 and 108. If you look at all those highlighted numbers, ask yourself, is there a number that you can factor out? And if you look at the 2, the 6, and the 108, The biggest number that actually divides into all three of those numbers is actually the number 2. All right, so usually one of the reasons why I highlighted that the 2 there is this is the number that you want to pull out of your trinomial before you start factoring it again. All right, so this green 2 is called the greatest common factor. So what you need to do is you need to remove the greatest common factor from the original problem. So when you're factoring out the greatest common factor, what you're doing essentially is you're dividing everything by 2. Okay, and then ask yourself, well, 2 divided by 2 is 1, so now you're left with n squared. 6 divided by 2 gives you a 3, so this will be plus 3n. Here's a minus sign, so that's minus sign. And 108 divided by 2 is going to be 54. All right, so if you don't have a leading coefficient of 1, then you need to factor out the greatest common factor. And in this case, the greatest common factor was 2. Most of the time, the greatest common factor for trinomials is usually the first number that you see, which was that yellow 2. All right, so now that you factor out your greatest common factor, you need to focus your attention on the trinomial inside the bracket. All right, so this is the trinomial that you want to factor, and you factor that by using the table method again. So the last number here is negative 54, and the middle number here is 3. So we need two numbers that multiply to negative 54, and those two numbers need to add to 3. So the numbers I'm thinking are 6 and 9. So 6 times 9 gives you the 54, but we need a negative 54, so one of these numbers has to be negative. And it's better to put the negative sign on the 6 because 9 minus 6 gives you the 3. All right, so then you can factor this trinomial here. This is going to be n and an n. So n times n. And then the numbers are now negative 6 and plus 9. So these numbers here, the negative 6 is there, and the 9 there is right there. And then finally this 2, it just tags along. And this right here is your final answer. All right, so most of the steps are pretty similar from the first method. You just need to factor out the greatest common factor. All right, let's take a look at question number 16 here. For this problem, the leading coefficient is no longer 1, it's 5. But then that means we should look at the other numbers here. So 5, 10, and 20. The biggest number that you can divide into all three of those yellow numbers is actually the number 5. So this is called your greatest common factor. And what you're doing is you're pulling the greatest common factor out right from the get-go. And when you're pulling out the greatest common factor, which is 5, what you're doing is you're dividing every single term here by 5. All right, so 5 divided by 5 is 1, so I'm left with n squared. 10 divided by 5 is going to be 2, so this will be plus 2n. And 5 goes into 24 times, so this will be plus 4. And now your goal is you want to factor this trinomial inside the brackets by using the table method here. So the last number here is a 4, and the middle number here is a 2. So two numbers that multiplied to 4 and add to 2. Well, unfortunately, we can't really do that. So 1 times 4 is 4, and 2 times 2 is 4. But there's no way these numbers can get us the 2 here, right? We just can't do it. So this right here is just our final answer. So our final answer for this one is 5 times n squared plus 2n plus 4. That's our final answer. Okay, let's move on to a few more. Question number 17. So the leading coefficient is not 1, it's 2 in this case. So that means we have to look at all the other numbers here. And the biggest number that I can pull out from all three of those yellow numbers is the number 2. All right, so if I'm pulling out, once again, this is called your greatest common factor. And if I'm pulling out the greatest common factor from the trinomial, that means I'm dividing everything by 2. All right, so 2 divided by 2 is 1, so I'm left with k squared. 22 divided by 2 is going to be 11, so this will be plus 11k. And 60 divided by 2 is going to be 30. All right, and now the goal is I want to factor the trinomial inside the bracket there in yellow. So now I need to set up a table here, and I need two numbers that multiply to 30, and those two numbers need to add to 11. So the numbers would be 6 and 5. 6 times 5 gives you 30, and 6 plus 5 gives you 11. All right, so let's break down my bracket now. This would be k and k. K times k is k, or k squared. And then we do plus 6 and the plus 5. And then this 2 here just tags along. So this right here is your final answer. And I mean, that 6 is right there, and that 5 is right there. So these kind of problems in part 2 of the video, it's you just have to do one step at the beginning, and that's remove the greatest common factor, and then the rest of the problem is very similar to setting up a table, just like the problems in part 1. All right, question number 20. There's a 5 here, a 30, and a 40. The biggest number that divides into 5, 30, and 40 is 5. So 5 is your greatest common factor. And if you're factoring out the greatest common factor, which is 5, once again, you're just dividing every one of these terms by the greatest common factor. So 5 divided by 5 is 1, so this will be v squared. And then 30 divided by 5 is going to be 6, so minus 6v. And 40 divided by 5 is plus 8. All right, and now the goal is I want to factor this inside trinomial by using the table method. So now I need two numbers that multiply to 8, and those two numbers need to add to negative 6. Well, two numbers that multiply to 8 are 4 and 2, but since I need a negative 6 there, we can put negative signs in front of both of those numbers, because if you multiply two negatives, that gives you a positive number, and negative 4 minus 2 is going to be negative 6. So if I want to factor this now, this will be a v and a v, because remember, v times v is v squared. And this will now be a negative 4 and a negative 2. And then this 5 just carries along. It just tags along. So if I use my blue marker here, here's my negative 4. There's my negative 2. Here's my final answer right there. All right, just a few more to go, and then we should be done this very first review video here. And for question number 21, there's a 2, a 2, and a 4. So the biggest number that divides all three of those yellow numbers is 2, right? So if I'm factoring out the greatest common factor 2, I'm just dividing every single term by 2. So that gives me the p squared. That's 1, right? So plus 1p, I guess. 4 divided by 2. How many times is 2 going to 4? 2 times, right? So that'll be minus 2. All right, so now you are factoring this trinomial here. And once again, we can do that by setting up a table. We need two numbers that multiply to negative 2, and those two numbers need to add to 1. So the combination that would work would be 2 and 1. So 2 times 1 is 2, but since I need a negative 2 and a positive 1 here, I should put the minus sign right there with the 1. So 2 times negative 1 is negative 2, and 2 minus 1 is going to give me a positive 1. So now we factor this. This will be a p and a p. Remember, p times p gives you the p squared. And then I need to add the plus 2 and the minus 1. So there's that guy there, there's that guy there, and this guy right here just tags along as a 2. So this right here is my final answer. All right, for question number 22, my leading coefficient is no longer 1 again. So I mean, this very first number, 90% of the time, this is the number that's your greatest common factor. So we're going to pull that out of the trinomial, and we just divide every single term by 4 now. That gives me the v squared. 4 divided by 4 is 1, so negative 1v. 8 divided by 4 is 2, so minus 2. All right, let's take a look at this middle expression here. And in order to factor that, I need to set up a table here. My numbers are negative 2, and my middle number here is negative 1. So two numbers that multiply to negative 2 and add to negative 1, well, that's going to be negative 2 and positive 1. So negative 2 times 1 gives you negative 2, and negative 2 plus 1 gives you negative 1. All right, let's finish off this problem here, v minus 2 and v plus 1. That's my final answer there. All right, let's go on to the final question here, number 26. So once again, the leading coefficient is no longer a 1. And most of the time with these problems, 9% of the time, that first number, which is the leading coefficient of 6, that's usually going to be your greatest common factor. And then that means you can divide everything by the 6 now. So that'll give me a v squared plus 11v plus 10. Okay, so that's very similar to just dividing all the numbers by 6. And then set up your t-table here. The numbers I need are now 10 and 11. So that one's not too bad. That's going to be 10 and 1. 10 times 1 is 10, and 10 plus 1 is equal to 11. All right, so this guy just carries down 2 brackets, v and a v. V times v gives you the v squared. And then we use these numbers here, plus 10 and plus 1. All right, so that concludes the video for factoring trinomials. Hopefully this was a decent review for how to factor trinomials when you have a leading coefficient of 1. And if you don't have a leading coefficient of 1, look to factor out the greatest common factor.